Welcome to the INSEC 2020. My name is Tom Petzold and I'm a scientific employee of the Professorship of Micromanufacturing Technologies on the Chemnitz University of Technology. I'm working in the field of electrochemical machining and I want to show you the laboratory for immersion-based electrochemical technology. Please follow me. First of all, I want to show you the setup for the Ecm technology. You can see here, we use it in several projects, and one of these projects is the Switch Ecm project. In this project, we want to machine a workpiece with multiple machining areas, and therefore we developed a multi-cathode system. The project is managed by the VDI Technology Center and is sponsored by the German Federal Ministry of Education and Research. In this project we made preliminary examinations for the removal characteristic of the bores and to get the research for the electrolyte flow. Furthermore, we created an interface to handle the positioning and measure the parameter sets. And on the other side, we have the immersion-based plasma electrolytic polishing process, which will show you my colleague, Mr. Igor Danilov.
Hello, my name is Igor Danilov. I'm a scientific employee at the Professorship for Manufacturing Technology at the Chemnitz University of Technology. Started to work with plasma electrolytic polishing, or shortly PEP, within the EU project Microman. Within this project, we investigated the process parameter of PEP and influence of this parameter on the results of polishing. And here I want to show my simple setup. Here you can see a laboratory glass with a metal sheet cathode that is placed on a heating plate. This heating plate keeps the temperature of electrolyte constant. The temperature of electrolyte is controlled through a thermal element that placed inside. The sample is connected as an anode to the power supply. The power supply is connected to the PC and controlled through LabVIEW software that is running on this PC. So here you can see a user interface of this software. So now I will show you a short experiment. Our ongoing research is focused on investigation of the plasma gas layer that is formed around anodes within the process. And to investigate this plasma gas layer with the optical methods, you need to keep electrolyte clean and transparent. For this purpose, we investigate a new electrolyte with another chemical component. So here you can see an example of PEP process. Here we have an electrolyte with a temperature of 70 degrees Celsius. The working voltage of 270 volts will be applied and the sample will be immersed into the electrolyte. As you can see, the plasma gas layer is building it around the anode sample. So when the voltage is applied and the sample is fully immersed, the process reaches its maximum current, and afterwards it's slightly decreased, what can be easily seen in the current plot. So here you can see an example of the polished sample after PEP. As you can see, the bottom part of it that was immersed in the electrolyte is shiny and polished, comparing to the upper part that was not polished and still is rough and matte.
Additionally, we are working now on a new setup for PEP. Implementation of a new setup with development of a custom control software will allow us to address larger sample surfaces, as well as further development of more complicated immersion strategies for reduction of the ignition current.
At the end, I want to give you a short information about the outlook and future research topics. In the field of electrochemical machining and thinking, this will be the investigations of experiments for magnetic materials and the magnetic field in the process and how it influences the machining process. In the field of immersion-based plasma electrolytic polishing, this will be the investigation of the gas electrolyte layer and furthermore electrolytes for machinable materials. Thank you very much for your attention and have a nice day.